Today I'm going to look at reviewing all the laws of indices that we have looked at, and hopefully by the end of the lesson we should be able to apply our index laws to any sort of scenario. So the first thing that I would do, and if you know me or you've been taught by me, you'll know that I prefer to call them index shortcuts because that is simply what they are. They're not just some law that we've made up out of nowhere for people to follow. They're actually just there to make our lives easier and actually stop us writing out loads of working out. So first of all, I'm going to derive the first law. By looking at 2 to the 5, I know this is 2 multiplied by 2 and repeated 5 times. 2 times 2 times 2 times 2 times 2. That's fine, we can do that, we can write it out long ways, but let's think about a scenario where if I had 2 values multiplied together, so let's say 2 squared multiplied by 2 cubed, if I write this out, I would have 2 squared, which is 2 multiplied by 2, and I would have 2 cubed, which is 2 multiplied by 2 multiplied by 2. What I could do is I could work these out as values, so it could be 4 times 8. However, what I'm going to do is try and write it in index form. So I'd look at what I've got in my longhand. 2 times 2 times 2 times 2 times 2. There's 5 2's here, and similarly to what I've just suggested, this must be equal to 2 to the 5. So what I'm going to do is I'm going to think about how could I get the answer of 2 to the 5 by looking at my indices, and we should be able to work out that 2 plus 3 would give us 5. So we have to add our index, add our exponents. So let's write this as a rule. So formally, we would say that x to the power of m multiplied by, well, it has to be the same base number, x, to the power of n, would give us x to the power of m plus n. And again, what I'd like you to look at is that we're just looking at the powers, given it has the same base. So once we've got that, we've got a rule for multiplying. It would make sense to try and think about a rule for division. First of all, I'm just going to go through an example, because if ever I'm stuck on something, I'll just write down an example. So let's say 3 to the power 4 divided by 3 cubed. And I would write this out longhand. To do a division, more often than not, we see it as a fraction. So I'm going to do 3 multiplied by 3 multiplied by 3 multiplied by 3, all over 3 multiplied by 3 multiplied by 3. Now, what I'm going to do is I'm going to think about my division, and I know that 3 timesing by 3 and then dividing by 3, that's going to cancel each other out. Likewise, I can cancel out everything, so I'm just left with 1 3 on its own. Well, if I had 5 2's, that was 2 to the 5, so as I have 1 3, this is 3 to the 1. So, again, looking at my indices, how do I get from a 4 and a 3 to get a final answer of 1? And most of you could have guessed this from my previous rule. It would be x to the power of m divided by x to the power of n would give me x to the power of m subtract n. So looking here at my exponents, my indices, we subtract them to get our final resultant power. The last one that I'm just going to talk about now is this is where we have some value and we raise that value to the power. So let's imagine that I have, not x, let's say 3 squared, and then I want to cube this. Well, just going to make a note up here. If I had x squared, that is x multiplied by x, because that's happened twice. So if I have 3 squared cubed, that is 3 squared multiplied by 3 squared multiplied by 3 squared, because it has to be whatever I have the value of cubed. We can use my first rule here by taking the sum of the exponents. So I would write this as 3 to the power of 2 add 2 add 2, which would be 3 to the 6. And again, like with my previous 2 examples, I'm going to think about what can I do with these values here to get to my final value of a 6, and that leaves us with my final rule, or shortcut, to be x to the power of m, all to the power of n, would be x to the m n, where we are multiplying them. And again, what I'd like you to do is take note of these rules. I would write them down, and then I'd like you to try and apply them to these questions on the left-hand side. So I'd like you to try and simplify these, please. So pause the video and have a go at these questions. Okay, so thank you for pausing. What I'd like to do is just quickly mark your answers, and then we're going to have a look at another application of these rules. So, well done for marking them, just give yourself a score. And now we're going to move on to negative and fractional indices. So these are going to be negative and fractional. And we're just going to use our 3 laws that we had last time to sort of derive pseudo laws for negative and fractionals. Again, the reason we do this is just to make it shorthand. So, the first thing to think about is if I have an answer and it is negative, how on earth could I get that? So I'm going to work backwards now. I want my answer to be x to the negative 1. So the way I can do that is if I think about my division laws and I subtract, let's say, x to the power of 0, and I divide that by x to the power of 1, well, that would give me x to the power of 0 take away 1, which is x to the negative 1. But now my issue is, what on earth does this look like? What does x to the power of 0 divided by x to the power of 1 look like? So what I'm going to do is again, I'm going to think about how I could rewrite this. Well, if I was writing it out longhand, x to the power of 0 over x to the power of 1, I would write it as a fraction. And anything to the power of 0 is equal to 1. So therefore, x to the 0 over x to the 1 is 1 over x. So therefore, what I've managed to get is a 4th law for negative indices. So x to the power of negative m equals 1 over x to the n. So if we have a negative, what I like to do is cross the line, change the sign. So as you cross the fractional line, you need to change the sign, and vice versa. You could do that either way. And finally, the last thing I want to look at is, again, thinking about a fractional indice. So quite often, when we're looking at fractional indices, we want to think about what would happen if I had the x to the half multiplied by x to the half. Well, a half add a half is equal to 1. We know that x to the 1 is just x, so what value multiplied by itself is going to give us x, and the only other way we know how to write this is using radical signs, which is the square root of x multiplied by the square root of x equals x. So therefore, from this, we would know that these two values must be interchangeable because they do the same job in this sum. So my final rule, I can say that x to the power of a half would be the square root of x. So therefore, if I think about this as a fractional power, my 1 is going to be the power here, and my 2, my denominator, is going to be the power of my radical. So therefore, if I had something which was x to the power of m over n, my m would be attached to my value of x, so it'd be x to the m, and my n would be the power attached to my radical sign, which would be n. So x to the power of m over n is equal to the nth root of x to the m. Now this is a little bit harder to apply, but again, you'll often be able to do these questions by taking the nth root of whatever value is first, and then scaling up by the power of m. So, what I'd like you to do is have a look at exercise 2. And pause the video now, and then I'm just going to show you the answers. So, that brings us to the end to our index review. If you have any questions, please let me know, and thank you for watching, and I'll see you in the next one.